in this example, and you may have seen this before, so I'm going to change this up slightly or move this around slightly to make it a two-tail instead of a one-tail. But at any rate, what you have here is there's a two-sample t-test, or there's basically two groups that have been tested, and one is with a placebo and one is with the depression medicine. And what you're going to find is that there were 40 subjects for the placebo and 42 for the treatment group that had the actual antidepressant. In this case, it's fluoxetine. Okay, there's a 12-week study, and as I mentioned, I'm going to move this around a little bit and do it no change. So that's going to make it a two-tail analysis. Okay. Now, if it said improvement, then it would be a one-tail analysis. But I just want to make sure that you're seeing a couple different views here for how to analyze this problem. Okay. All right. So each of these, this is the variable. Okay, this is the variable placebo, and this is the actual fluoxetine. Okay, and so what you're seeing here, and this is the actual printout from a two-sample, or from it's a t-test, a two-tail t-test. This is the output. So you're getting a slightly different look here, and so instead of you having to calculate what these values are, you'll be given this output from Excel or whatever software we're using at the time. In this case, we're definitely using Excel and the StatPack, or as you might know it to be as the data analysis tool, which is over on the right hand side of your screen as you're running the StatPack tool inside of Excel as optioned for data analysis. All right. So you're seeing a couple different things here. You're seeing, 6.65 is the higher, the happiness index is kind of a happiness index, as you always say. They feel less depressed. So 8.82 is better than 6.65. And so what we really want to find out is this difference that you're seeing here, the lift in lower depression, okay, or happier, let's call it a happiness index or non-depressive index, is that lift, is that enough to say that statistically at a 95% confidence level that this fluoxetine, as we had back here in our original discussion, fluoxetine as compared to the placebo group, does it help? Okay. So we'll be referring back to that, and here are the different, the various outputs, as I mentioned, 40 and 42. These are the variants, but those don't come in real important right now. And here's the hypothesized mean difference, and you hypothesize that the difference is 0. So that's the null hypothesis, is that they're equal. The degrees of freedom, it's already calculated for you, and then you have a various number of statistical measures and their actual values. And what we're going to be homing in on is kind of here and here, because I'm doing a two-tail analysis. So let's take this from the top. What is an appropriate problem statement? Well, the problem statement here is and it's really more of an opportunity, if you will, but you want to make sure that the drug works. That the fluoxetine, okay, the example here, fluoxetine, positively affects depression. And why is this important? Okay, is that clearly if this is the depression market, or the drugs, or this is $1-2 billion market space. So if you put something out on the market that doesn't work, then you've wasted a ton of money. And so that's the reason for, as with anything else, when it comes into, for the most part, in business and other situations as well, you want to make sure that you're making a positive effect on depression. Okay, so what is an appropriate research question? Okay, basically, does the depression medicine work? And as mentioned, we're going to do this one on a two-tail analysis. So what we're doing here is we have two hypotheses. We have mu sub, or not two hypotheses, two mu's. Mu sub 1 is equal to mu sub 2, and the alternate is mu sub 1 does not equal mu sub 2. And so I'm going to declare mu sub 1, that's the placebo, and mu sub 2 is the fluoxetine. So as you can see, it looks like there's a lift, but let's just make sure that indeed that's the case. What type of hypothesis test would you conduct? On this one, as mentioned, I'm going to do a two-tail T at 95% confidence level. And I'm going to actually, as far as the methodology goes, you would mention at that point that you're using Excel StatPack, but not really all that important for testing purposes. Okay, what confidence level? You're at 95%, sig .05, p less than .05, right? So that should do a two-tail T. Yeah, so we're good. And then the next question is, what are the critical values for the type of hypothesis test selected? So we're going to do a two-tail T. Now the good news is, from the handy-dandy report, it tells you exactly what the critical value is. Here's T critical value two-tail. If we were doing a one-tail, you would use either minus 1.66 or plus 1.66, depending upon how you set up the hypotheses. Okay. So what is the critical value for the hypothesis test selected? It is 1.99. So that is T, and that's T sub alpha over 2, just to kind of signify that this is a critical value, not a test statistic. What is the test statistic? Here it is. T-stat, test statistic, is minus, so T is equal to a minus 1. I'm going to round this up a little bit, 1.65. So we're pretty well set, and then we're going to come in here, and based upon this output, okay, and this we're going to use the critical value method first, and then we'll just use the p-value. The p-value is going to be really quite easy, obviously, because it's already given. But what you're doing here is you're doing a t-test. And it'll take off artistic ability or lack thereof, and you split this out, 0.025 and 0.025. So these are the reject the null, and this is do not reject the null. So as before, there were two areas under that curve where you would reject the null. And here, if you do not reject the null, obviously there's no difference between the two means of 6.65 and 8.3. All right, and you have your critical value, 1.99 on the upper tail, minus 1.99 on the lower tail. You're testing to figure out whether these are 0 or not. Just like we did here, the hypothesis, or the hypothesized mean difference. And your test statistic is still minus 1.65. So what happens here is you come in here, you go minus 1.65, you're falling kind of down in this area in here, and that's in the do not reject the null hypothesis. So up front, when we get the actual printout, where we ran the numbers on a descriptive basis, you can see here they looked different, but indeed on a sampling basis at 40 and 42, okay, you would not be able to infer that there is a difference based upon the sample to the overall population. at a 95% confidence level. Okay, now you come in here. To verify this, you come in here and you go, okay, so what is the p-value, the actual p or alpha? Okay, that would be another, this is the error that's actually occurring at the statistical value or the test statistic of minus 1.65. And you can see here it's 0.103. So p is equal to 2.103. And so we had our standard that p less than 0.05. In order to reject the null, 0.103 is greater than 0.05. So here again, we would not reject the null. And what you would conclude, unfortunately, in this situation for the drug company, is it looks like at a two-tail analysis, at a sample size of 40 and 42, it's the p-value is 0.10, so it's not even really close. And that's proven in two situations. One is 0.103, and then you're well below the minus 1.99 at 1.6. So the recommendation here, if I were the drug company, the sample size is a little bit low. The first thing I do is increase the sample size. And retest, or not retest, but reevaluate the findings. And the reason I would do that is if you look at the other statistical measures going on here, here's the p-value at a one-tail. So the one-tail, it's pretty close. And you can see that the critical value is, this would be minus 1.66. You can that kind of bears itself out, because what would be going on here if you were doing a one-tail analysis is you would have something like this going on. Okay, and I would do just put it down there, minus, so this would be a minus 1.66. Or actually minus 1.67, rounding up a little bit, 1.67, okay, and this would be the do not reject, and this would be the reject, okay. And you can see here that if you took the test statistic, again, of minus 1.65, this one's dangerously close to working itself out, but right now, you'd have to say at this point, without a reevaluation or increasing the sample size, you probably wouldn't spend much more money on this product, especially as it relates to trying to affect depression levels. So going back to the original question, is the treatment group less depressive? And the answer is a clear no. So this is a loser. And the reason you wanted to make sure of this is because you don't want to roll a product out to the market that doesn't work. And in this situation, you're finding it doesn't work. I'm closing the loop on the whole discussion. It doesn't work. So this would be this would probably be one that you would not push forward at this point based upon the data that's available. That would be the business decision.